Okay, welcome back. We have a problem on trig. We are given that sine x equals to 5 all over 13, 0 degree less than or equals to s less than or equals to 90 degree, and we are asked to find cos x minus 2 sine x all over 2 tan x. This is a boundary condition that shows that is a right angle triangle, and we are given that solution. Let's solve this. We are given that sine x is equals to 5 all over 13. So we can show this, represent this in a right angle triangle. And we have a right angle triangle like this. Okay, so here is the angle x. So we say that sine theta is opposite of hypotenuse. So this is our opposite, the side facing the theta. So we have 5. Here's the hypotenuse, that is 13. So we don't know here, is an unknown. Let's use y. So how can we get here? We get this side by applying the Pythagoras theorem. We say that by Pythagoras theorem, we have that the square on the hypotenuse side is equals to the sum of the squares on the other two sides. So the square on the hypotenuse side, that is 13 squared, is equal to the sum of the squares on the other two sides, that is 5 squared plus y squared. Right, so 13 squared is 169 is equals to 5 squared is 25 plus y squared. So let's make y squared subject to the formula. We have that y squared is equals to 169 minus 25. So that y squared is equals to, when you subtract this, you have 144. So when I take off this square here, I bring in square root. So y is equal to the root of 144 will give us 12. So that means y here is 12. Interesting. Now let me get the value for cos. Let me get the value for cos x and tan x. If I not substitute it in this in this pattern, when I substitute it here, then I can now solve and get my final answer. Okay, now we have that cos x is, what is cos x? Cos is adjacent over hypotenuse. So this is adjacent, this is hypotenuse. So we have 12 over 13. So we have 12 all over 13. We've already been given that sine x is 5 all over 13. Cos x is 12 over 13 from here. Now what is tan x? Tan x, look at, I gave you SOHCAHTOA. Please don't forget this. It gives you a reminder to understand this. Now tan is opposite all over adjacent. So we have, this is opposite, this is adjacent, right? I told you that opposite is the side facing the theta, the hypotenuse is the longest side, then the other side becomes the adjacent. So this is opposite over adjacent, that is 5 all over 12. So you have 5 all over 12. Interesting. Now we are given to find this. We want to find this, right? So we'll write it out here. We have cos x minus 2 sine x all over 2 tan x. Now what is our cos x? Cos x is 12 over 13. You write 12 all over 13 minus 2 sine x is 2 multiplying sine x. What is sine x? 5 over 13, right? 5 all over 13 all over 2 tan x. 2 multiplying our tan x, that is 5 over 12. Right, that's nice. Now let's continue. Here we have 12 all over 13 minus 2 times, here you're going to have 2 times 5, here is 10 all over 13 over, here you multiply. Okay, instead of doing that, 2 can still cancel the denominator here to have 5 over 6. So we write 5 all over 6. Now let's subtract this. Since the denominators are the same, what you just do is pick one of the denominator. Now you subtract the numerator. 12 minus 10 will give you 2 all over, you have 5 all over 6. So what do we have here? We have 2 all over 13, right? This is division line that is divided by 5 all over 6. Sorry, we have 2 all over 13 divided by 5 all over 6. Okay, so that's what it means here. So we have 2 all over 13. Changing this division sign to multiplication, this turns upside down. You have what? Instead of 5 over 6, you have 6 over 5. Right? Okay, so now, can anything cancel? I don't think there's something that can cancel. The numerator and the denominator, nothing can cancel, so we multiply straight. 2 times 6, you have 12. 13 times 5. 13 times 5, you're going to have 5, 1, that's 65. Okay, 65. So we have 12 all over 65. So that is the solution for cos x minus 2 sine x all over 2 tan x is equals to 12 all over 65. That is given that sine x is 5 over 13 at this interval. Okay, so I hope this video is helpful. Thank you very much.